Hello, everyone. We'll start the webinar now. So welcome to the TMC Pool Fund Study Emerging TMS Topics webinar series. Today's webinar is titled as Using Geofencing to Actively Monitor and Collect and Share Information. My name is Anaf Moshed, and I'll help facilitate today's webinar. As a quick reminder, at National Operations Center of Excellence, we offer a variety of resources to support the transportation systems management and operations community. You can go to NOCO's website to browse through links for TISMO resources and news. Previous webinar recordings and case studies can be accessed from here. Now I'll cover a few logistics for today's webinar. We are recording this webinar, and the recording will be available on NOCO's website. All the attendees are encouraged to stay engaged by using the Q&A feature for questions and chat feature for comments. These are both on the bottom of your screen. So at this point, we will conduct a couple of poll questions. So bear with me while I launch the poll questions. So you will see a couple of poll questions. What organization are you affiliated with? And then once you answer that, you can scroll down and see the second question. What is your role with traffic management systems? So I request all of you to go ahead and participate in the poll questions, please. I'll give it a couple of minutes. Yeah, if you can scroll down after you finish answering the first poll question, if you scroll down a little bit, you'll see the second question, which is, what is your role with traffic management system? And the options are traffic control management, traffic incident management, traveler information, maintenance and construction, performance monitoring and evaluation, researcher, service provider. So I see almost 75% of the participants have participated. I'll just give a few more seconds and then I'll close the poll. Those who have joined us late, please go ahead and participate in the poll questions. We have a couple of poll questions. First question is, what organization are you affiliated with? And if you scroll down after answering the first question, you will see there's another question, which is, what is your role with the traffic management systems? Thank you for your participation. Now I'll share the result. As we can see, most of our attendees are from public agency and federal government. There are also private agency folks here, a few from academics, and then others. And for the second question, we have experts on traffic control management, 21%, and traffic incident management, 19%, and then research, 19%, and performance monitoring, 12%, and service provider, 14%. So we have a good blend of expertise and attendees from different agencies and organizations. So at this point, we have there are a few webinar learning objectives for today. So in this webinar, we're going to learn about the TMC Pool Fund Study and the work it is doing to identify and address the key issues and challenges faced by TMCs. Second one is to identify potential opportunities to use geofencing to actively monitor, collect, and share information. And finally, to hear about lessons learned from agencies who are using geofencing to collect traffic and incident data and send travel alerts or information to specific geofenced location. The webinar agenda is packed with great topics. So we're going to have a TMC Pool Fund Study overview provided by Suzette, Peplinski, and then we're going to move on to a topic called Challenges with Traditional Methods of Travel Information and Potential Geofencing Solutions by Liz Jacobson, and then Agency Practice and Lesson Learned from Caltrans in Colorado by Sri and Bob, respectively. And then agency practices and lesson learned from Pennsylvania DOT by Ryan McNary. And then finally, we'll have a Q&A session and talk about the future or upcoming webinars that we have. So at this point, I'm going to hand it over to Suzette, who is a region traffic safety and operations engineer at Michigan DOT, and she will be reviewing today's agenda. She'll be reviewing today's agenda and providing an overview of TMC PFS, who is co-sponsoring today's webinar. So, Suzette, the floor is yours. Thank you.
Thank you, Anna, and good morning, everyone. Just welcome you from the Traffic Management Center Pooled Fund Study. And I guess just a brief overview of what the Pooled Fund Study is. If you can, next slide, please. Oh, before we get into that, just a comment on all of the presentations in today's webinar. The FHWA and the Pooled Fund Study do not endorse any of the products or anything that is presented. The names that are used for individual manufacturers are purposely for because that is what was used on the projects and not to endorse any products. Thank you. Next slide. All right, so what is the Pooled Fund Study? The TMC Pooled Fund Study is specifically for states with traffic management systems and traffic management centers. And we have been in operation. I've been involved for, I think, 14, 15 years. And I think it's been close to 20 years that this Pooled Fund Study has been together. And it's a group of public agencies and organizations, mostly state agencies. I believe we're at about 22 states right now, state DOTs that are members. And the members put in funding. Each member puts in funding into the pool, and then we use it each year for identifying and selecting research and projects that we deem as important to the group. We'll go through and flesh out ideas and come up with problem statements each year and vote on them. Each member gets to vote on which projects we move forward. So overall, the goals of the group are to promote TMC's performance, capabilities, and better manage the resources that we have. Next slide, please. Our TMC, one of the big benefits I've found, like I said, I've been a member for at least 14, 15 years, and it's a forum for TMC managers, people involved in the TMC world, to network with each other and share information. We do a lot of share best practices, the things that don't go so well, and have a lot of those conversations. We have an annual meeting where we meet each year and talk through a lot of that, as well as selecting our projects. The projects that we do to develop various technical resources which help address key challenges and issues that we all face. So it's really been a great resource for everybody involved, I believe. We'll discuss and brainstorm solutions to common issues, share best practices, as I said. And it's really a good collaborative group to have those people that you can reach out to and ask questions on various things TMC. If you are interested in more information, you can always contact John Obenberger. Also, I think on the previous slide, there was the web address for the group, which lists all of the research that we've done so far, plus what we're working on right now. Next slide, please. Speaking of, we are currently working on, we have 7 open projects right now and a couple upcoming projects. A lot can let you read the list of them, but everything from kind of strategic direction of traffic transportation management systems to social media use by the TMCs, staffing plans, even with a whole project on open source or agency-owned softwares and different APIs. So really getting into the technical details of a lot of the things that we face as TMS operators. And then the first one on this list, sharing information on TMS emerging topics, is the one that helps us generate the webinar series that we sponsor. Next slide, please. Oh, and before I move on to that, we also have a few projects that either topics that we'll identify as a pooled fund study group that either we can't fund with our current funding, or we discover that other NCHRP is already working on the topic. So we do partner and support NCHRP projects as well. And there's three current ones listed on this slide. Next slide, please. Another resource that's that we've developed in collaboration with NOCOE is the TMS portal that's on the NOCOE webpage. This is a portal that has pulled together the various technical resources, not only that have been created by the pooled fund study, but others that have been posted by states or agencies around the country. The portal is just kind of a one-stop shop for agencies to access and share information on the TMS related issues. And I really encourage you to take a look at this site. If you ever have a topic that you're wondering about, you can go and you can search on here and look through. There's a lot of just even short white papers on different projects that states have done. And it's a really good resource of information. It's been a great partnership with NOCOE. Next slide, please. And then today's, again, back to our project that is the TMS Emerging Topics webinar series. We sponsor, along with FHWA and NOCOE, sponsor every other month a webinar on a technical topic. Sometimes it's one that we've had research on, sometimes it's a new topic. But today's webinar is a result of that, which is the using geofencing to actively monitor, collect, and share information, as well as the other topics that are coming up, which I think we'll review also at the end of the webinar. So with that, we will get started on the topic of the day. Next slide, please. So to get us started with our topic today is Les Jacobson. He's the principal at LNJ Transportation Consulting, and he'll be providing kind of an overview about why this is such an emerging topic right now. Take it away.
Suzette. Thanks, Suzette. So one of the things I wanted to start with was just what our role as the team supporting this particular project it does. We essentially take one of the topics that the pooled fund study has identified, along with where they know of some applications to that emerging topic. We do a little bit more research on that, and then we produce a white paper for the TMC pooled fund study only. And after we have kind of the issues down and where things have been tried and what those experiences have been through the white paper, then we develop a fact sheet and a presentation, like the presentation that I'll be giving today. I also wanted to say that about this presentation today, like in most of them, I will be covering some general issues, some lessons learned, some things that we found from as many applications as we looked into. But I will also do just a quick bit on those applications themselves. Now, what happens after me is a lot of the people who actually invested in and developed those applications and implemented them we'll come up and go into more detail on those. So my role, other than kind of setting the stage and saying what we found from all of kind of common themes that we found from all of the applications, primarily it's just to introduce those so you know what some of the applications have been, and then we'll go on from there. Next slide, please. So one of the things that comes up is when an agent is trying to get real-time travel information or road condition updates that are specific to travelers' routes, there's a number of methods that might be able to gather that information. Some of the traditional methods are through things like changeable message signs or 511 services, but often it's tough to provide specific or route specific or location specific information through those more traditional methods. And also from a data collection perspective, it might be tough to cover everything and everywhere that some sort of congestion might occur or a collision might occur that travelers need to know about. So a lot of the agencies have looked into some new approaches, some new technologies, perhaps some third-party service providers that can provide for those needs that I've just covered. So one of the things that's important is if those come up, how might an agency incorporate or integrate those technologies into their existing traffic management systems? Next slide, please. So one of those topics or one of those mechanisms is geofencing. Geofencing is the use of GPS information to create this kind of virtual boundary or fence around some geographic area. And what that does then is it allows people within or crossing that fence or that geofence to get specific information that's relevant just to that specific area. So it can trigger a response in the software when there's a mobile device entering or leaving the geofenced area or even inside the geofenced area. And then it allows an agency to get information like crowdsourced information, perhaps, that's within that area. And also it enables the agency to provide information to travelers through some mobile applications or alerts, or even a portable or permanent CMS that can then provide that information that's very specific to the location that the person is in. Next slide, please. So just some things to think about with the types of situations or scenarios that you might want to have this specific information. One's around a road closure. For whatever reason the road closure might be, it might be a work zone, it might be a natural disaster that is closed either lanes or all of a roadway, whatever the case may be. So when there is a road closure downstream of where the motorist is, then the motorist can receive some sort of automated alert if they're within that geofenced area, like maybe an example might be 10 miles within from the closure. It might be smaller than that, depending on the road network. It might be larger than that. But when that occurs, then that information is sent directly to the motorist. It might also be related to road weather. So if the road weather information system reports that there's really bad weather, poor visibility, whatever the case may be, then the CMSs within the geofenced area could display a specific message to the driver about that specific condition that will be ahead. that information could also be sent to the motorist through some sort of alert or third-party app, whatever the case may be, or in some cases, the agency itself has that app that motorists can download. In any case, when a motorist would approach any sort of slowdown, could be construction activities or any of the things that I've mentioned before, is that there would be an automatic alert to the driver about the slowdown and maybe how long it's thought to be in place, any sort of information that they have. It also can be used for maintenance workers, and they can receive a warning if a vehicle enters the geofence above a certain speed or some other things, so that they are aware of what the conditions are and they can be on the lookout from a work zone safety perspective. Next slide, please. So excuse me, some of the benefits of geofencing. One, drivers can make better informed travel decisions before they reach a slowdown or a closure, whatever the case may be. Some drivers may only want to receive relevant alerts that directly impact their specific route, so they don't get inundated with a bunch of information that they really don't have any use for. And then also work zone safety can be improved because construction workers might be better informed, but more importantly, drivers will be better informed of the work zone coming up, and they can adjust their driving behavior accordingly, which provides safety for both of them. Also, agency can save costs because they're using third-party service providers for data collection and also for information dissemination. So, and they can also get kind of this crowdsourced information from the people who are traveling through that specific geofenced area. Next slide, please. So what agencies hope to get from geofencing is a method to augment their traditional methods to deliver traveler information and to collect information. It helps them actively monitor travel conditions, and then they can share information not only with the public, but also with other agency staff and service providers. It allows them to leverage mobile applications and information from those third-party providers, and that means that their costs for data collection and information dissemination are reduced. And finally, it can deliver automatic and immediate information to travelers that is relevant to their specific trip. Again, so the drivers don't have to cull through, or the travelers don't have to cull through a lot of information. It's also important to note that the idea here is primarily to have the types of alerts and things that the driver doesn't have to spend much time on, can see quickly in a glance or from a verbal notification, so that they know what's up ahead without having to take their attention away from their driving task. Next slide, please. Of course, there's some challenges, and one of the ones that first came to my mind anyway was, well, you could send a lot of information, and that might be too much. The travelers might be overloaded. So how does the people who develop this system decide how much information is too much and what is the right type of information? Also, it might be difficult to really determine the specific cost benefit to make sure that it's something that's worth doing. There may be costs of third-party service providers, costs of an agency providing hardware and software, and just trying to understand what those costs, not only initial costs, but ongoing operations and maintenance costs might be. Also, there might be policies and procedures and standards that need to be looked at and identified, maybe developed, or others that are changed to make sure that data formats will work with the existing TMS, that alerts and messages will be uniform and clearly understood. Other challenges is how to customize those alerts based on travel location, travel directions, the specific routes that they're on. So again, they don't get information that is not relevant to their trip. And then another one that could be challenging is sharing that information among agencies within and in neighboring states as well. Next slide, please. So some of the enabling technologies and methods that we found, a lot of times, whatever it might be, whatever application, it's important that there's some sort of application program interface or API that allows and enables the geofencing, and it allows that data transfer between different software packages and different sources of information. And it also allows agencies to share information directly with third-party providers. Also, travelers receive that relevant information when they travel through the geofenced area. And so it's important that the technologies that travelers might have are things that whatever the application is might be able to use, so that they can pay closer attention, and also so they don't need to search so much for relevant information. And as I mentioned earlier, alerts are usually provided audibly using hands-free technology, so they don't have to take their eyes off the road, and it's less distracting and easier to understand. But it's also important to know that there needs to be some technology in the vehicle. It doesn't have to be technology that is provided by the vehicle manufacturer. It could be through smartphones, typically is, but some way that the technology is in the vehicle. Next slide, please. So there are some geofencing tools that have been developed either in-house or with third parties. And it's important to know that requires some ongoing care and feeding, some operations and maintenance, staffing and resources that are required. And most all the time, service providers are going to require some sort of contract to help with their ongoing costs. It's also important to know how it might fit in with your IT policies and what procurement requirements might be to get those, to enter into those contracts with the third-party providers, and also to know what type of information is considered sensitive and should be guarded, so that you can protect personally identified information, and because of that, it's really important to include your IT staff whenever you're looking at something like this, both in planning and then especially during procurement. So there are a few examples, and other people will be talking about these, so I'm going to go through this pretty quickly. Caltrans has an application called Quick Map, which is enabled by geofencing, and it allows partners with a location service provider to determine when a driver is in the geofence, and then the travelers can use either a website or mobile app to sign up for the customized alerts, and the TMC operator, the TMS operators can generate those messages and send it out. And it integrates with this specific lane closure system that Caltrans has developed. Next slide, please. Colorado DOT also has an application called Co-Trip Planner, similar in many ways to California. But this one was developed by a third-party provider. It includes a feature that detects a user location and immediately provides a summary of relevant traffic incidents, and it identifies the traveler's direction and speed, and sends those alerts, in this case, within a 5-mile radius. And again, it's integrated with the state's TMS. Next slide, please. Pennsylvania DOT has an application, 511PA, that also uses geofencing. It was developed by a third-party provider, and it sends alerts specific to their GPS location. And this one allows the travelers to receive alerts within a certain radius, from 1 to 500-mile radius in all directions, or just in the direction of travel. So the user can kind of tailor that a little bit better than if it was a static kind of selection process. It also includes some roadways in neighboring states. Next slide, please. Also, PennDOT has an integrated queue detection system, and that allows virtual queue detection because it's integrated within their TMS. It allows when a vehicle goes in, and as vehicles travel through, they can detect slowdowns from that information as the vehicles go through. They can also assign CMSs to geofences within that software, so that information can come up that's specific to their location. Next slide, please. And with that, I will pass it back to Suzette. Thank you, and I'll be around for any questions at the end.
Thank you, Les. And yeah, as Les said, we're going to plan on doing live questions at the end of or after the presentations. But please feel free to put your questions in the Q&A pod as we go along. Some of them may get answered by presenters as we go through, but any of them that do not get answered as we go through, we will do live questions at the end from what is in the Q&A pod. So next up, we have from Caltrans, we have Siri Balasubramanian, who is the Deputy Division Chief of Traffic Operations at Caltrans, and will be talking about their use of QuickMap.
All right, thank you, Suzette. Appreciate FHW and others giving us this opportunity, or giving me the opportunity to share information primarily about the lessons learned that as we implemented push notification as part of QuickMap. Next slide, please. So hello, everyone. My name is Sri. It's a lot easier just to say my first name as opposed to my last name. And I'm the Deputy Division Chief of Traffic Operations for Caltrans, or the California Department of Transportation. Before I get started, I do want to acknowledge, Jamal Kareem, one of my coworkers here, and his team from Caltrans IT for their help on this project. Caltrans, as you probably know, or California, has a large network of state highway system. We have over 15,000 center line miles, over 52,000 lane miles. They cover all types of terrain: mountains, valleys, deserts, coastal areas. In 2021, there were about, we calculate VMT, and we had about 180 billion was our annual VMT for that year. Again, to have a reliable system and make sure it's an efficient system, we have to provide traveler information. Travel information is provided through multiple ways. You have seen before, and less shared information through changeable message signs. And one of the tools that we use is QuickMap. QuickMap has a lot of information on it. As you can see on the slide here, it shows information on lane closures, full closures, any incidents on the highway. It gives information that we share on the changeable message signs. You can get information from the cameras, information about the rest areas being open or closed. We also added information on the commercial vehicles, information specifically for commercial vehicles. So I'll cover quick map mostly, but I also want to touch upon what we're using geofencing for our Caltrans fleet or Caltrans equipment. But quick map will be primarily the focus, which is more external facing, and then the Caltrans equipment is more internal facing that we can use to monitor and make choices or decisions. Next slide, please. So, how did we get started in the push notification? We have had Quick Map for a while, and then unfortunately in 2018 we had a situation where one of our bridges in a rural area was closed. It was an emergency closure, and with no detours leading up to the bridge for a few miles. And so when the bridge got closed, we couldn't convey the message. There was no changeable message signs in that area. We couldn't convey the information to the traveling public. As a result, traffic backed up. There were people trying to turn around, do a lot of things, and it got a lot of people excited. And one of the things we were challenged to do was, hey, can't you find a way to provide information to the traveler? Can't you send some notification to them? So that got our folks thinking about, okay, how can we get this information through? So our goal was to provide advanced traffic notification. Obviously, that would then, if it's a closure, reduce congestion, travel time efficiency. So a lot of things would come out if we are just able to notify people in real time what the conditions are based on where they are located, as opposed to overall sharing of information. So with that, next slide, please. We did some market research about who can provide us this kind of service. We looked at our own staff, IT staff, to see if we can develop something. We created a proof of concept where the goal was to allow the users the ability to opt in as they sign it. This is in addition to our quick map. So people download the quick map, and then if they want to get push notification based on the geofencing, then they would, we'll give them an option to sign up for receiving those push notifications. The system is fully automated, meaning it takes the information from the closures, displays it, sends the push notification, or in some situations, it's the TMC operator can then notify or put the push notification out there for people to receive the push notification. Next slide, please. The system was designed to intake closures from the internal system, or what, as Les mentioned, our lane closure system. It automatically takes that information, creates a geofence, and then when that information is provided to a location service provider, whenever a location service provider tracks the device as it enters the geofence location and notifies us, and then we send the information to those people who have entered the geofenced area. The notifications are received by the device, whether you're in the Quick Map app or not. It doesn't have to be actively running. Once you sign up for the for the push notification, you get that information on your phone. The notification is delivered to the device within 3 minutes of entering into the geofenced area. Next slide, please. So we put the system into action, or it went live on July 27th, 2022. When we first started off, we wanted to have some limited functions to see, how does it work? Does it make sense? What kind of feedback we're getting from the public. So what we did was we used it for planned full closures only, not lane closures, not partial closures, full closures, which last 30 minutes or longer. It's on the conventional highways or any highways. If our ferries are closed, we would push this notification. Rest areas, like I mentioned before. So there were certain applications or certain situations where we would do it, and they would get 30 minutes in advance of the actual closure. So if we have a planned closure that starts, say, at 7:30 in the morning or 7 o'clock in the morning, starting 6:30, they'll get a notification saying that, hey, the road ahead is going to be closed at 7 o'clock. So they have advance warning, they can plan their trip. But there are also times when we have emergency closures. So in those cases, the notifications are sent immediately. If there is a closure, the notification goes out when you're within the geofenced area. Again, full notifications for snow conditions. That was another thing we tried because we have a lot of freight movement on some of our highways where we need to let them know as soon as they a notification goes up because of snow conditions, because they change back and forth pretty quickly. Next slide, please. Just a little bit of information on statistically. We had 16 million push notifications sent out last year, and we had about 60,000 users who had opted into receiving the push notification. Once we did the initial notification, then we said, okay, how else can we improve, or what are the type of information we want to share? So here are what you see there are some of the cases that we have started doing. In fact, the first one we are getting ready to implement it. Again, this week being the National Work Zone Awareness Week. Close to that, we are releasing this notification, push notification feature. When somebody is entering or getting close to enter a work zone, or a work zone is upstream, they get a notification informing them that there's a work zone ahead, to be cautious and to watch for workers and slow down. That's one application that will be going out pretty soon. The other thing is border wait time. For our border with Mexico, we wanted to share information on the border wait time so people know how long it's going to take for them to go across, to go through the border checkpoint. We currently have that available statically on a quick map, but also trying to give them a push notification so that they can make a decision on when to pull over and wait. Like, say, for example, a cell phone area at an airport, you can park there, wait, and when the travel time or the wait time goes down, you can then head out. Again, if you can afford that, head out to the checkpoint. Also, the travel time notification in some key areas, we're looking at providing them. Chain control closures, which is something, again, in the mountains, notify them so that people don't crowd the highway and park on the highway itself. What we have not done yet, and we're looking at, is the audio notification. Having it on a screen is one thing, but just getting an audio notification is another thing. So we're looking at that option as well. And one of the things which has impacted us a lot is the wrong way driver. Some way, somehow, if we can notify other people of the existence of a wrong way driver, it would certainly help, because wrong way collisions, though there are not many of them, but when they do happen, it's a pretty serious one. So that's another enhancement that we're looking at in the near future. Next slide, please. As I mentioned, I'll briefly go through this. All of our this is where we're using geofencing for the internal facing feature. Caltrans equipment, most of them have a GPS locator on it, and so we know exactly where it is located. What we can do is, right now we are using it for tracking winter operation vehicles. So that's what I said when we had the quick map information. We show where the snowplows are on the highway. So as you're driving on a highway, if you have that feature, you can see where a snowplow is, and you can make sure you avoid them or give them enough space for them to do their job. But we also use geofence for other things. So, for example, in Southern California, where there is an air quality management district, we try to monitor to see how many of our fleet is within that area. What's our greenhouse gas emissions there? How do we make sure we don't have too many vehicles in an area if it's not needed? We also we can keep track of vehicles entering and leaving a maintenance station. Equipment, we have started buying EV fleet. So we have an area around EV charging station, our own EV charging station. So as they enter it, they can kind of check and see how much battery power they still have left, and then based on that, make a decision to use that EV equipment in that area. Again, there are a lot of equipment that are equipped with this feature, and then we can put, say, for example, a geofence around, and if there is an incident, we can figure out put a geofence there and figure out what kind of equipment is available there so that we can then dispatch that equipment to the incident as quickly as possible to address the incident. Next slide, please. So these are a list of lessons that we learned. You know, as we use this, you realize that there are a lot of things you can do with geofencing. You know, the shape itself. You use a circular or linear. In many cases, we use the circular one, and we give a certain radius. You know, we use 10-mile radius for most of the things. Like for the work zone, we're using a 5-mile radius. In some cases where the decision point is further away, we can then change that radius as far as how far you can get that information. Again, with the circular and linear, you want to make sure if there are no side streets coming in, do you need to have a circular one and people just get that information when they're not even going to get on our highway. So those are the times when you decide, okay, in this case, maybe we should go with the linear one. Whether it is automated or customization, we use right now automated for most cases because we have so many closures. You cannot have somebody sit there and you know, even multiple people are entering it. You don't want to spend a lot of time entering it. So it automatically picks up the information from our lane closure system, creates a radius, and sends that information out. So whenever somebody gets into that area or the geofenced area, they get the message. The number of notifications. This is a huge one. As it was previously mentioned, how much notification do you give? How much information do you give where it becomes a distraction? So that's why we are slowly increasing the use cases to make sure that you're not inundating a traveler with a lot of information and a lot of distraction. Once you have the geofenced area, the type of uses we have is almost limitless. You know, what information you want to convey to the traveling public. So again, that is one of the things that we are monitoring. You know, keep the number of use cases to where it is efficient and effective in conveying the message to the traveling public so that they can make informed decisions. Again, there is a question about monitoring and sharing information. You can monitor a lot more information and then make decisions and share the information that you want for the traveling public. Again, when you share information, this is another lessons learned as far as do the traveling public need that information or is it something they want? One of the things we found out when people realized that we can share this information to the motorists, and a lot of motorists in some areas, you know, based on the traffic, there are a lot of people who are in that area. People started asking us, hey, can you put public service announcements, you know, things like that are not directly related to your traveling needs, because this is one way of getting people's attention in certain areas. So certain regions started asking questions about, can we put, you know, health-related information? Can we put, you know, weather-related information that is not directly going to impact you at that time? So that's where, is there a need or is there a want where people want to provide that information becomes a challenge. The data volume, you know, when you start putting a lot of this information and a lot more people start using it, how do you store the information? How do you, you know, provide this information? You may need multiple terabytes of space to kind of store this information. And then the cost. So far, what we have found based on the information that we are providing, the cost has not been significant. But as we add more cases, as we add more information, as more people sign into it, we'll have to determine what it would cost us to be able to provide this information to the traveling public. Again, geofencing is a very powerful tool. We need to see how we can harness it for the traveler benefit, taking into complete account the safety of the traveling public. The safety of the motoring public is our top priority, but also an informed motorist can make a safe decision in advance. So we need to harness the power of geofencing that is available to us as technology. So with that, I'll stop. Thank you, Suzette. Returning it back to you.
All right, great. Thank you, Sri. And next up, we are heading to Colorado for Bob Fifer, who is the Deputy Director of Operations at the Colorado DOT, and he will be telling us about Colorado DOT's use of the Co-Trip Planner.
Thank you, Suzette. Next slide. All right. I want to kick off. Let me give you, not that our system's 100 years old. It would be amazing if we were, but let me kind of give you some background of who I am and where I've come from. I moved to CDOT and became a public servant about 7 years ago. I'm actually from the industry, both in the telecom and IT industry. So I brought some perspectives to the DOT that would increase our efficiencies and leveraging technology to work smarter, not harder. So let's dive right on. And our advanced traffic management system is really kind of the heart of what we do and how we log our work, what we transact with the technology. And that has to be the vehicle that feeds into our Co-Trip, our advanced traveler information system. That feeds it and informs what we're doing. Back in 2003, we did develop an in-house on-premise, so that means servers within our own data center, that hosted the Colorado Traffic Management System. We refer to it as a CTMS. At the time, we built a website that was associated directly onto the same servers and directly connected into our advanced traffic management system. And so therefore, when people were leveraging Co-Trip back in 2003, you would actually be accessing it through the internet into my data center and where I hosted that website. And then over the years, we integrated our video management system into Co-Trip, and we went through many different variations over the years. In fact, painfully, my team's probably a little worried that I'm about to go to another system to stay ahead of advanced technology around video. But in 2021, we decided, or as my team would say, I decided, but our team decided to look at how do we move from an on-prem to maybe a cloud or hybrid solution, which is both on-prem or off-prem. And that is not so custom made, because our previous ATMS was custom made to our needs and was very successful, strong brand and heavily used. But how do we move into an off-shelf to reduce the maintenance? How do we implement and integrate in video management in the ATIS or our Co-Trip? And then how do we develop more redundancy? And so in 2021, we did an ATMS, ATIS, and a video management system conversion in one night. We converted over to our new system that I'm about to show you. So can you go to the next slide? So why? Meeting the need for speed, and no pun intended, but basically the point we were at in 2021, we were spending about $1.8 million on maintaining. It was a combination of our ATMS and our Co-Trip, and it was causing some stresses onto our budgets. We were seeing over 2 million daily website hits that were growing. And then we didn't have a mobile application. We had some knockoffs that were trying to take our information and regurgitating into an app, but we didn't have an official state app that would help users make those decisions that Suri were talking to. The more informed the traveler is, the safer and more thoughtful decisions that they make when they plan their travels through our state. But also what was happening was the response time, the intelligence, the speeds, the data was starting to become overwhelming for our existing system. So we found, to give some example, we found that when we would have a snowstorm in our state, our system, because of the single entrance to access the website was on-prem on my server, we would overload our Co-Trip website when we hit the 2 million and higher, which would actually crash my advanced traffic management system, and which was not a good thing. So we had them connected, which was thoughtful and made it easier, but it also had some detrimental repercussions when our website was exceeding capacities of our server and our internet connection. And so it was tasked at the time as how do we resolve that? And then that's the journey. So part of this discussion is like, what are the lessons learned and what did we do to migrate from where we were to where we are today and then where we're going to the future? So let's go to the next slide. So the hunt, I call it the hunt because back in the end of 2020, we sent out an invitation to negotiate, which we were one of the first to ever do it, not an RFP, but an ITN that would give us an opportunity for people to bid on a new conversion of those 3 systems. One was you can come as a prime and then have some subs of other software to create a package that solved our issues. Or we could actually take pieces of each people's proposals and make our own package. We did decide to go with one, let's just say, for lack of a better word, a general contractor that had 2 subs and to replace all 3 of our systems. Within 9 months after that negotiation, we did implement it, and that was pretty remarkable for a DOT to implement a whole new systems like that. But we were looking at an 18-year-old system at the time that was homegrown and custom. And if anyone has gone through those custom systems, the older it gets, the harder it is to maintain and the more specialized it becomes. And so it got very costly. We needed to separate the cross dependencies between the ATMS and the ATIS because of that incident I shared. We were having downtime and impacts because of the heavy use of it, and our branding was so strong that people relied on the information we shared. So that led us to we needed more than a 99.9% availability for both systems. And then business continuity. How did we deal with like COVID, and how did we have an operations center, our traffic management center, to be able to stay up when we were dealing with a pandemic or any type of other emergency? It did show and highlighted some continuity issues between our operations and business. So how do we have a flexible system? Because the system was on-prem and it was one way in, the same way in as the CoTrip users at the time, that our operators who were remote were coming in and caused some performance issues to access the systems to, in return, share on CoTrip. But I also wanted one lens in which all 3 systems can look through, that an operator can do tasks, operate the highway, and be situationally aware of what's going on the highway. So we needed something adaptive, we needed something reliable and available, we needed something virtual. We had to reduce our systems. I think there was too many systems that my operators were looking at to get that information onto CoTrip. It was very manual, as well as maximizing our ITS equipment and data. And as it was brought up earlier, that asset and that system is expensive. It's collecting data. It's, we have everything from cameras and weather stations and variable message boards and variable speed limits and so forth. But how do we maximize that information and leverage it to improve the safety and the throughput of our systems? So next slide. So before you start that, just 1 second. 30 years of perfection. And what we mean is over the last 30 years, we've been trying to improve our engagement with leveraging our CoTrip with the traveling public and other media, the news and other sources. What we decided to do is kind of be able to leverage data sharing through APIs through our website. We actually through CoTrip, we share our data with anyone who wants to use it, to ingest it or digest it, to be able to do something with it or develop from it. And I'll explain kind of our strategies and why we went this way. But what we are seeing now, once we converted into this and we upgraded our CoTrip, because of the enhancements in what we were sharing, we were, as you can see here, we had over 2.3 thousand or 2,300 users per minute. When we have a snowstorm, we have over 6,000 active users every minute. We are getting over 129 million hits a year, which before we were barely exceeding 48 million. And we have 4.8 million active users in CoTrip. And what we found through this conversion, and when I decided to do this conversion, was let's share every data item we get, every ITS device. What does it do? What does it say? What is it telling? So that all that information is put on there. We also wanted to make sure that we have a voice to text. So when you're using the app and you're using our service, you are able to know what is going on in your vicinity within a couple miles, so that you can be not distracted. You can hear the alert while you're driving and know you might want to avoid that area. But also, we wanted to be able to let folks understand where our snow plows were. We recently, it's not on the slide, but we recently enabled an EV charging location, and we found that because we had the highest use about a month ago, we had over 6 million hits to our website in one snowstorm. It actually started exceeding our capacity, and our EV charging layer was causing some issues. So we launched something new that we had to pull back and relook at because of the heavy use of our system. But the idea, I'm going to show it here in a minute, is on the far left of your screen. We're going to go through what the app looks like, and I'll walk you through it. So why don't we go and get that started? So once you get into our app, you kind of can see all of our devices. But what I'm doing here is I'm actually going to set a location, and I'm going to use it as a routing system to give me a route to get from Golden, where my office is, to Boulder. And it shows all the devices and so forth. And if you look at the route here, it will show all the cameras along your route, starting in Golden all the way up to Boulder. You can see how traffic is. Down below, any variable message signs that are being shared down below are being displayed on real time. We also provide any weather information or anything else along your whole route. So once you set that, you can set it as a favorite. You can get alerts on that. So if this is your normal day, you will be able to get alerts before you leave at a certain time or when you're about to go home. But you can see everything you want to see there. You can click on the weather station and you'll know everything from what the visibility looks like to wind speeds. Every data point that RWIS shares, we put it in here so that everyone has access to everything that my operators will know at any given time. Let's see if we continue. And then there's an overlay. See, it went pink there. That was actually a storm system coming in at the same time, or a little cloud coverage. But you log in here into your account, and you create those favorites. Let's see if I have any more in here. Let it continue going through. Yep. What we're doing is on here is I'm zooming in on the devices. You can create layers as well. And here you can actually click on the camera and actually play the camera and see live movement of the camera. And then you can also create how your theme looks and how you want to set up. And here's your layers. Everything from welcome centers to weather to Waze. We even put Waze information, chain up stations, because that's the law here, port of entries, road conditions, express lanes, future construction is all on there, and provide those alerts. We also put mile posts. That was one thing that was important when people were trying to report something, they didn't know where they were exactly, because there might not be an exit or a cross street. So we have all the mile posts put in there. We use the Google backend mapping engine to do this, but we put an overlay of our information on that, as well as our routing for detours. If we do any detours because of a closed road, we do not leverage the Google routing feature. We put our routing over it because we don't want to divert traffic into local roads that may be more impactful than just following state highways around a detour. So next slide. So what was the results? At the end of the day, when we were finding that we needed to move into this newer version in this app and trying to communicate better, faster, quicker, more efficient with our traveling public, we reduced our operating and maintenance costs by over 60%. We increased our availability. We're actually hitting 99.999% availability. We've only had one minor outage in almost 4 years. We created resiliency. So our systems, so I know Sri was mentioning costs and so forth, but our systems, we actually have our ATMS inside of a Google Cloud, and we have our code trip in an Amazon Web Services cloud. And then we have some cross connections so that if we ever have an impact with our code trip app or website, that it doesn't pull down my advanced traffic management system like it did historically. So now we have cross dependencies. And then since we moved it to the cloud, we have resiliency that allows my operators to have remote access to be able to work remote and manage our highways if we have something that goes wrong in one of my 3 operation centers. but also to be able to allow the public to still access this vital information to make those decisions. And then we improved the customer experience at the end of the day. I mean, we really wanted to modernize the way that people access information, have accessibility, and kind of have an idea of what they're dealing with when they deal with our roads. We really promote this. We have a lot of tourism that comes in the state all times of the year. It's promoted at our airport and so forth to use and download the app. And finding a better way to find that information. We have one interstate that hits about 11,000 feet above sea level, and one tunnel that goes through there. And if people are trying to get back to the airport from the ski resorts, sometimes an hour drive can turn into a 4-hour drive. So we always say no before you go, just so that folks can properly plan. I will say with the app and with even the website, it's, as you can see, when we go from over 128 million hits now, that from 48 million hits prior, you can see the utilization that people would truly rely on our brand and rely on the application. So we've gotten to a point where, and this is where I'll go into some decision making that we're making. We strategically kind of took a different approach than Caltrans in regards to geofencing and really pushing stuff back. There is some interesting perspectives that could be shared with sending it back, but we also need to realize that most people will probably not come to our app to use routing compared to Google Maps or Waze or Apple Maps or TomTom. So what we really try to do is we will put our information and do what we've and share our information and share routing and provide those services. But we also work with TomTom and Google to really push our information that we have on closures, incidents, and so forth into their mapping services, so that not only do we not meet the people that meet our app, but we want all apping and navigation apps to get the same information, so that we have, no matter who you use, that we're impacting smart travel decisions. That's been a challenge. That's probably a whole nother webinar we should probably discuss, is how to get uniformity with those navigation apps. There's really only two. It's Waze and it's TomTom. Waze gives to Google Maps and TomTom also gives to Apple. And so the thing that we were finding is that the uniformity of the data we share is actually the GIS of our road is different than the navigation app's GIS system. And that's been a challenge to get them to understand that when I say there's a problem at this point, my point may be slightly different than their point. And so we use mileposts and they use exact GPS locations. So there's sometimes a disconnect of what those are. And we're looking at how do we cross-reference that information. But that is somewhere that we need to make sure that we're working closely through this information, is how do we work with other folks that might use similar geofencing or navigation apps, and how are they communicating with the public back. So next slide. So where are we going to next? So I mentioned EV charging locations. Like I said, we did put that layer on there. It was great. We have one of the most EV charging stations per square mile. We're the third in EV vehicles in the state, right, or in the United States right now. So we do have a lot of population that is interested in it. There are challenges with EV charging locations that, different people are brand loyal. They show a little bit different, locations or amount DC charging versus level 2 charging. Then the other thing we're moving into is variable speed limits. We do have a variable speed limit corridor where it adjusts by weather, queuing, and also traffic speeds. It is self-intelligent through our real-time data hub, and it does self-adjust automatically without humans involved. What we're doing now is, how do we notify law enforcement and how do we notify our public of what the current speed limits are? We did at one point publish our variable speed limits, but because the system is self-attenuating itself, it wasn't refreshing fast enough for our public as well as law enforcement. So we are putting a layer on there that if law enforcement pulled somebody over, they can actually look at our app and see what the speed limit is exactly at the same time. for that zone, and they will be able to write the ticket associated. Another, and probably the most important one we're working on right now, is making sure we're fully ADA compliant by being enhancements to the system for all user types. So we have some state laws that have put some very strict compliances on how our state websites will work and interact, and we're working through that right now, and that's been our top priority. And then I think the last slide is just my contact information. So I think that's all I have. Yep. Suzette, so if there's anything else, I don't see any questions. I think we'll move on. And thank you for your time.
All right, great. Thanks, Bob. Lots of good stuff there. Our last stop today is in Pennsylvania. Ryan McNary is Chief of Operations and TSMO Performance at PennDOT, and we'll be talking about their use of 511 PA.
And some other things. But yeah, thank you, Suzette. And thank you, NOCO and TMC Pool Fund for having me. So we'll get right into it. I realize we're up against lunch right now. So you can go to the next slide. So as Suzette said, Chief of Operations for TSMO Performance as well. So we do temporary traffic control, all the systems, the data, and then TMC operations for the state. So I'll be covering our first foray into geofencing, which was 511 Connect. Most of you might be aware of that from a different name, maybe 511 Help, where we landed with data-driven weather protection messaging and then probe data. And then I'll cover some future plans and some partnerships. So you can go to the next slide. So I'm going to start with 511 Connect for emergency operations. You can go to the next slide. So we developed this around 10 years ago in a partnership with Information Logistics. It's a way to communicate during our most undesired scenarios where we have trap queues out there during inclement weather, where temperature, roadway conditions are not in our favor. So this uses wireless emergency alerts. So we geofence a certain area, it will send out a WIA to that subject area, will then come over individuals' phones and they can opt in to have direct communication with operators in our emergency facilities. So no pre-registration, no apps. You can go to the next slide. It's, relatively accurate within 0.1 of a mile. This is something that we're always trying to refine, but with cell towers, it is generally the best we've been able to test and do. You experience these through Amber Alerts. National Weather Service uses these a lot, but it's something that we've had around, like I said, now for 10 years, and it's available to purchase through others. And so you can go to the next slide. Example at the bottom just shows how the in-app feature works from our operator's perspective when we're working an incident. So all those little dots are vehicles or individuals within the cars who opted in to get direct communication about the incident that they're involved in. And then on the right-hand side, it shows how we set up the messaging. What we don't highlight a lot is we can actually single out certain individuals and then talk to them directly if they have specific questions. So it's essentially like texting back and forth. It just puts us in the operator's hands to help the individuals in emergency scenarios. So you can go to the next slide. So I'm going to go sort of back in the incident progression here, but more chronological as far as what we've developed. So we wanted to understand the likelihood of what causes our crashes. And some of these are probably pretty intuitive to you all. So low visibility, high winds, freezing surfaces, freezing rain, slippery surfaces. you know, those are the likelihoods that we found around our road weather information systems that it would cause crashes by commercial vehicle and non-commercial vehicle. So freezing surfaces is, for example, non-dry roads with a surface temperature under 33. We tried to over-engineer this to come up with very intricate parameters, and it really was these simple parameters what was the tipping point where we started to see crashes. Now, slippery surfaces starts to get into grip level of the roadway, air temperature under 40 miles per hour, but this kind of was our aha moment where we started to understand, all right, we need to do something with this. So you can go to the next slide. So what you didn't see on that is whiteout conditions. So this is where we maybe got into the over-engineering. We wanted to understand, we have snow squalls in Pennsylvania, and you know, a lot of the northern states have these that are very dangerous, and they cause the headline news types of crashes where there's multi-vehicle pileups, 100 plus pileups, and we want to do as much as we can as a public agency to prevent those. So we have looked at multiple to understand what the conditions were and how they progressed. And we came up with that tipping point on the left-hand side there is there needs to be a snow or other form of frozen precipitation, visibility under 1 mile, rain intensity at a 0.04 above. And then we use that reading within a 15-mile radius of all of our ROS stations. That covers 95% of all of our interstates and major arterials. So if those readings and that threshold's crossed, we will post those messages that you see below there. So whiteout conditions ahead, reduce speed, be alert for snow squalls. Those are a little further away because, you know, they're fast moving, right? So that's something that we did. And then the map on the right-hand side just shows if it's a larger circle, the amount of readings we've had since 2018. So we're doing that right now. We piloted this up in Erie and on I-80, which is the northern east to west route in Pennsylvania. So we can go to the next slide. We also do high winds. So we had a new bridge open up last year that crosses the Susquehanna River in central Pennsylvania. And during the study, they have experienced very high winds, which would cause a very dangerous scenario because the trucks will be vulnerable. So we're using the RWIS stations that are located right there at the bridge to automatically post messages and to close the bridge. Now, there's no gates. It's more of a soft closure. I think they're investigating. Something just popped up on my screen. They're investigating potentially doing a hard closure there. And then we also do this for fog as well. So low visibility. Now, these are all tried and true measures that people in states and agencies have done before. We're just doing it more on a geofence virtual basis because from our perspective in Pennsylvania, we have seen very high device maintenance costs ballooning over the years, and we're trying to focus on connections that could better that cost for us in the end. So you can go to the next slide. So, okay, we're going to talk about queue protection and what we're doing to enhance our operations. Now, some of this information I've never shared before because we just started running some safety data to understand if this was working. So you can go to the next slide. So why we're doing this. So there was a Carnegie Mellon study, I want to say it was like 2 or 3 years ago, where they tried to understand likelihood of a crash and then offer parameters around types of work zones that increase the likelihood of crash. So it's not essentially like crash rate. Like we from the safety perspective, we can always understand crash rate. It's very easy to do, but likelihood is very difficult sometimes. So I was very interested in this study. So 1.8 miles in length and heavily traveled, so high ADT routes. And I put the links to the study in there. But what we've always wanted to do is, okay, Q detection, Q protection has been shown to reduce 18 to 45% of crashes in work zones. There's a study there that was done, I think, by Texas, if I remember correctly. But essentially, what we wanted to do is, all right, that is a great example of an ITS solution that can help us. But the problem that has always been is they're expensive. You have to rent the equipment. It's isolated to certain work zones or certain locations. So how can we rethink this? So when we were designing certain features for our ATMS platform, we decided, well, you know what? We have vehicle probe speed data. Let's check the latency on that. And we think it would work for this. So we tested, and we came up with a solution about to share. You can go to the next one. So a little background here, when we were doing our testing and our analysis, and Les went over this a little bit before, these are all data-driven messages. So the example messages you see there, that XX is a placeholder. So it's going to dynamically calculate where that back of the queue is and how far away it is. But this was another aha moment, that there's 47% of these crashes in work zone congestion occur 2 or more miles back of the beginning of the work zone. So in my opinion, I think there is an operations solution that we can do to help prevent those crashes. So that's where we came up with where we're going with this. So you can go to the next slide. So setting up a probe data queue protection. So you have to geofence the area in our software. We wanted it this way because, for example, the map you see there is a construction project. It's a very long construction project. It's a major rehabilitation to I-78 outside Allentown, going to Harrisburg. And we wanted this because there's safety plans for construction projects that are going to be different. And we wanted to have a little control over where this is going. But I could see this expanding to being just something that's integrated into your ATMS system. So you geofence that, you identify the devices and the messages that you want. Legit, that is exactly what we request from our engineering districts. What devices do you want to use? The messages you want to post. So if you see on the top yellow banners there, under 45 miles per hour, recorded speed under 25 miles per hour. We consider that stop traffic because the delta between the speeds seems like people are stopped when you're going that slow, when you're driving down the road. But the tricky part about this is, how do you get those dynamic messages to calculate the miles? So we actually have to build segmentation into the corridors by each mile segment. And those thematic colors you see down there is just a representation of what it looks like and what it does. So each mile segment at 25 miles per hour, it would post a message upstream that stop traffic. You're going to experience it in, say, 2 miles, for example. You can go to the next slide. Okay, so that project on I-78, pre-post. So same 6 months, 2021 to 2022, we saw a decrease of 12% crashes, a 23% decrease in the number of injuries that occurred. What was, I would say, what stood out to us on this was the injuries. And one thing from a traffic management center policy manager aspect is, I'm a driver too, and I see messages posted out there that I don't trust, and I work for the DoD. What we're trying to do with this is be more data driven, regain that trust from our citizens and visitors that are driving through Pennsylvania. So we thought that this solution would do that. So we've now created around 20 probe data queue protection corridors around the state. We're covering, that should say lane miles, I apologize. So it's covering over 600 lane miles of roadway. Still a lot. There's no additional cost for implementation, and it flexibly accommodates, you know, construction projects who don't have the budget for this. So you can go to the next slide. Okay, so this is some information I've never shared before. I figured this was a good forum for it. So we now have enough data that we consider enough data. So 2 years of data for 11 corridors. And we wanted to understand, are we making a difference here? And we think we are, but you all will probably be the judge on that. But we saw, you know, the total crashes were reduced 11% across all 11 of those queue protection corridors from 1808 to 1625. So a decrease of around 185 crashes. What was impressive is 96 of those were rear ends. That's what we would expect. 86 were injury crashes, but 7 fatals. And when we isolated the fatal crashes, and I have a history in safety. I don't normally call out fatal trends because they're so unpredictable. When we dug into that a little bit, those 7 fatal crashes that we saw were heavy truck. Giving this information specifically to the truckers, we saw the biggest improvement for their heavy vehicles to slow down, giving them this information. So 1/3 of the corridor saw fatal and injury crashes decreased by over 20%. It also, when you're reducing those incidents, we reduced around 75,000 vehicular travel time. It saved us around $3 million in project costs, because like I said before on the last slide, there's no cost to the construction projects to do this. We just set this up from my system team, and what we found through the equity of this, we offered queue protection for around 4,500 short-term work zones and almost 3,000 incidents. So we're trying to protect for secondary crashes in all these areas. So these are some of the most troublesome roadways that we have in Pennsylvania. So we're starting to expand the application of this even more. You can go to the next slide. Okay, lessons learned. When we entered into the scoping and design of this, it really had never been done before. So people were scratching their heads looking at me from my systems teams and my vendors. But we got there, and especially my TMCs around the state. But we've had a lot of lessons learned, and I can't cover them all. But so here's some information. So not every corridor is gonna be able to accommodate this. So make sure you do your due diligence, and you're constantly refining based off of results that you see. For any ICM, make sure you add the algorithm configurability versus hard coded. So we do use this in ICM outside of Philadelphia on Interstate 76. Make sure you set up the startup process as simple as possible. That was simply the spreadsheet that I showed on the previous slide that we give the engineering districts. They submit that, and then my team is off and running, and we can build that. Run a historical speed analysis. That's pretty straightforward. I think everybody understands that. Add a spatial and time configurability to the equation. So we have business rules that are enabled as part of this. So the example I'm going to give here is when we first were starting to enter this, we would post queue protection messages just when it was detected. And then what we had to enhance to was if there is a slowdown already and that message board is there, you can't post a message because people will get kind of mad at it from the public perspective. It's like, all right, I already am stopped. Thanks, PennDOT. And then just test with real data. So you can go to the next slide. Future plans. Go ahead. Okay, now I have to give Florida credit here. Florida DOT with, gracious enough to help us piggyback off of their efforts on their connected vehicle data exchange. So we are partnering with Florida on this. They're the leaders on this one. We have not built anything yet, so if you want any more specific information on this, but we are building a data lake or a connected vehicle data exchange right now, where we think this is going to set us up to do more geofencing that we consider and send us down the direction of almost virtual ITS solutions. You can go to the next slide. And one of the first things that we want to do is protect our mobile work zones. And this is a very timely presentation. Unfortunately, we had a mobile work zone struck last night, and 3 of the construction workers died. And it's, I think, across the nation, something that I think everybody experiences. So we have integrated 5,000 AVL into it, and we're going to try to geofence mobile work zones so we can post protection messaging as they're moving down the road on our existing CMS. So that's everything I wanted to share. Thank you.
All right, thank you, Ryan. We are going to head into Q&A here. We are running short of time, so obviously if you need to drop off, that is your choice, but we are going to run through some of the questions. I guess a couple of them were related to work zones, so maybe we'll keep Ryan on the hook here for a second first. One of the questions actually that I had, I think you kind of answered in your last slide. Is the work zone data exchange part of the data lake that you're creating with Florida?
Yes, it is. Yep,
Okay,
everything
so
is going to be work zone data exchange compliant. Yes, we're a big
Okay.
supporter of that.
Okay, excellent. Because yeah, that would be a great tie-in for this kind of thing.
Well, and Suzette, real quick, let me add on to that.
Sure.
When you talk about sharing our, let's just say, ATMS data into whatever app or geofencing system, the navigation companies are trying to standardize around the work zone data structure, and so more DOTs hooking into that will actually help a bunch of different navigation systems and geofencing systems to standardize our data structure. So I don't know if people knew that that's what Google and Apple and some of the others are trying to do, is standardize around that data source. So the more information as DOTs can share into there, the better the work zone information can be shared out.
Right, absolutely. And the other work zone related one was, are there audible alerts for impacting the work zone? If so, how loud is this audible alert? I think they mean like in vehicle alerts. So that's more related to the Caltrans system.
No, I don't think we have audible alert in the Caltrans system at this time. We're looking at getting audible alerts within the vehicle, but we don't have it right now.
Okay. And we'll open this up for anyone. Are any of the panelists aware of efforts that utilize geofencing to facilitate the support of roadside features, like work order management, arrival and departure times, etc.? Do any of you have those type of features incorporated with or use geofencing for any of those features? Sounds
This
like
is again Sri from Caltrans. As I was mentioning in my presentation about the internal use, we have used geofencing to see when vehicles arrive and leave our maintenance station. That's just a particular use that we have currently.
okay. All right. Also for you, Sri, while you're on, there's a question. I've noticed that on RIDIS, California has virtual CMS on the traffic map. Is this tied to your geofencing alerts?
At this time, no, it's not.
It's not part of that. Okay. Also for anyone, what types of companies create the geofencing? Is it based only for mobile apps and the mobile user apps?
We don't really use any geofencing on the mobile apps per se. I mean, I guess our 501 app does, but all the other geofencing that I talked about is done at the operator level.
Okay, so that was part of your ATMS system in that case then, right? So it was built into your ATMS?
It's part of it's multiple systems, but yes, ATMS and then other separate systems.
Okay. Also one for you, Ryan, on the last presentation, how were you able to identify that the 7 fatalities that didn't happen were in truck-related crashes?
So my bureau manages all the crash information for the department. So we have all the vehicle information that is involved in crashes. So that's simply the delta that we saw between before and after. As far as we saw, there were 13 truck crashes that resulted in fatalities. And then after this, there was 6.
So just comparing to historical. Yes.
Yeah.
Also for Ryan, do you train operators to do the two-way communication for the WEA, or can any operator do two-way communication?
Yeah. So a lot of training goes into that. You know, sometimes it's just simple, rudimentary, communications training of how to talk to people and stuff like that. But we do almost biannual training as far as that system with all of our staff that uses it.
Okay. Let's see. There's no questions there. What have any of you seen any specific, I guess, limitations or drawbacks to using the geofencing within, as a technology within the application that you're using?
I think the drawback for us is just how data is shared, stored, and user approval, privacy. We've kind of tried to stay a little bit away from any of those kind of PPI that Sri and others have brought up. That puts us in a different game, especially with open records and so forth. So, I think in our thought, I mean, we'll do some generic geofencing kind of information, but at the end of the day, we're really going to, kind of rely on others to really kind of share that data when you use the other services. That's kind of our focus right now. But, there's some interesting perspectives that the other DOTs are doing around it that gives good alerts. But again, our concern as well is over using information, getting too noisy in the vehicle or the driver, and they just get numb to it. I'm sure my peers here, Ryan, Suri, and others, since we deal with operations, if you're part of me, I get a text every time somebody dies or something happens on our road, and you become numb to the noise, and we don't want that to happen as well to those that are using the app or the services. We want it to be effective in there. So we still find, even though our app is heavily used, we still find our variable message boards are probably the most effective forms of communication quickly right now. So.
Yep. Okay. Well, that does, let me double check. Okay, one more question in the Q&A. Do you conduct data validation before dissemination to the public? I know, Ryan, you addressed that in your presentation. Are there any others? What do you do for data validation?
Depends on what the data is. I'm sure if we all look at it, sourced data, crowdsourcing data is as good as who's putting it in, right? So like Waze is a good example of it. We have to be careful of what we receive before we reshare it. We don't typically reshare the data, but we do a validation of our core data that comes off of any of our ITS equipment to validate so that we become the source of truth to anyone else that uses our data.
Okay, anyone else want to share on that one? All right, that clear. Oh, go
The
ahead.
only thing I would say is we're not immune to errors. You know, data is not immune to errors. You know, similar to what Bob said, and we've had errors, and we just, you know, that's why we put it in the hands of our operations 24/7 staff. So if they see the errors, we can deactivate. So it's not going to be up there posted on the CMS where it can't be taken off or disabled. So that's how we've adjusted it. But I will say, and I'll add a caveat there, the errors are few and far between with what and I'm specifically talking about the Q protection. I think we've only had one corridor where we've had to custom and reach out to the data provider.
Okay. Do you find, you said you're using probe data for that? Is there latency? Has latency caused any issues?
No, that was our biggest concern with the design, and I think the latency when we tested it was 5 to 7 minutes. And I think when we're dealing in miles here of Q, that generally the latency is good enough.
Okay. All right, great. Thank you to all our panelists for taking the time to pull everything together for this presentation and sharing your time today. Our questions are cleared out of the queue. We're just gonna cover real quick. Again, we have some products with the TMC pooled fund study that are close to publication. We have one managing TMS assets that's available now. There is a link to our website for the completed project documents on the slide here. The slides will be posted on the NOCOE website at probably about a week, usually for processing the webinar. And the slides will be posted. Next slide, please. And we do have several upcoming every other month. We have a great topic to share with everyone and great presenters like we had today on a variety of topics, and that is a list on your screen. Next slide. And a reminder again, the TMS portal is a great resource for lots of things, you know, as well as the whole NOCOE website, frankly. I go on there a lot of times when I'm looking for something new and do a search on a topic. It's a great resource. Next slide. And I'm going to hand it back to Anaf for the final poll and closing out the webinar.
Thank you, Suzette. So you can see the poll questions on your screen. So please go ahead and answer those questions. And you can see a couple of questions here. If you could just type in, are there any types of information, resources, or research conducted you would like to see that are not currently in the TMS portal? If yes, please specify. And if you have any additional TMS emerging topics that you would like to see covered in an upcoming webinar, please state that as well. So I'll give it a couple of seconds, a minute or so. Go ahead, please type in if you have anything to add to that. All right, so I'll end the poll results here, poll questions here. So, yeah, thank you everyone for attending today's webinar. And I also want to thank our panelists. We had a great discussion here today. As I mentioned in the beginning, a recorded version of this webinar will be available on NOCO's website. And on behalf of NOCO and our presenters, thank you for joining us today and have a great rest of your day. Thank you.